Okay, the domain of a quantifier, uh, or sometimes you can also refer to this as the context, is quite important because it can determine the truth value of the statement. See, for instance, this statement, for all x real, x squared is greater than x is false. Why? Because when x takes values between 0 and 1, this statement is not satisfied. And of course, there are real numbers between 0 and 1. Therefore, there are x values that violate this statement, which means the statement is false. However, if you restrict the x values to natural numbers, 0, 1, 2, 3, 4, etc., then this becomes true because 0, 1, 2, etc., for all those natural number values, this statement is now true. This illustrates that depending on the domain of discourse, a quantified statement take a different truth value. So this is quite significant. Another example is given here involving the uniqueness quantifier. There exists a unique x that is a real number, x squared equals 1. This is clearly false because you see um, negative 1 is also a solution in addition to positive 1. So you have at least two. You have two solutions in the real line for this equality. Therefore, it's not unique. Therefore, this statement is false. But again, if you restrict your domain to positive values, then this means the only value that satisfies this equality, plus 1, makes this statement true because it exists and it's unique. It's the unique solution in this case. Therefore, this statement becomes true. So the message here is the domain of discourse related to a quantified statement is quite significant and it can determine the truth value of the statement. Now, sometimes in the notation, in a mathematical text, you can observe such domain restrictions imposed on the quantifiers. But if you'd like to be quite rigorous, you can also eliminate it from the representation. But here you need to be careful. For instance, um, take the existential quantifier. In this statement, we have the domain D. So there exists an X in domain D. D could be any set you can think of. Or if you're not talking about numbers, it could be some other structure. P of x. Okay, there exists an x in domain D, P of x. That is our statement. Now this can be alternatively expressed as there exists an x without specifying the domain. Now you specify the domain now inside the statement, not in the quantifier, but you push this information into the actual statement. So there exists an x is in domain D, and at the same time, P of x. Okay, so this is the way you eliminate domain dependence from an existentially quantified statement. Here's an example. For all x negative, this is my domain of discourse. For all x negative, x squared equals, I'm sorry, this is of course the existence. There exists an x that is negative, x squared equals 10. Okay, so what this statement says is consider all possible negative numbers. There's at least one of them which satisfies x squared equals 10. Okay, I can express this again by there exists an x such that it is negative and at the same time its square is equal to 10. So you just push the domain information inside the statement. Now, when it comes to universal quantifier, it gets a bit trickier. Okay, so take the original statement for all x in domain D, P of x. Now it's not for all x. X is in D and P of x. this is not equivalent to this statement, okay? And you should think about this for a minute if this is not clear to you. This is quite important. The correct way to do this, to eliminate the domain from a universally quantified statement, is for all x in domain D, P of x, this is equivalent to, for all x, if x is in domain D, then this implies P of x. Okay, this is the correct way to push the domain information into the proposition when you have a universally quantified statement. Okay, so here's an example. Let me clear this one. For all x negative, x squared is greater than x. Okay, for all x negative, x squared is greater than x. This is our original statement. Now we would like to express this without any domain restriction in the quantifier. So we should write for all x, x negative implies x squared greater than x. Okay, now for instance, you can translate this to natural language and then think on this. But let me point out to you why it's not the other way. Why is this not equivalent to for all x, x less than 0, and x squared greater than x? Okay, so for a minute, let's think about what this statement is saying. For all x is negative, and x squared is greater than x. Okay, so this doesn't say when you have a negative number, its square is going to be greater than itself. It doesn't say that. What it says is any number you can think of, okay, it is negative. Not only that, and its square is greater than self. Okay, so there, in the nature of the original statement, there should be an implication. If your x is in the domain, then it satisfies the statement, because that is what universal quantification does. Any element in your domain, it satisfies this. That intrinsically gives you an implication. But if you remove that implication and replace it with conjunction, this leads to a different statement. What you are saying here is for all x, or essentially for all numbers are negative and satisfy this, which is not clearly the same thing. Okay, here's another example. There exists an x in this room. So this room is my domain now. I'm talking about stuff in this room, okay? Objects or beings within this room. That is my domain. There exists an x in this room. X is an engineer. So what I'm saying is there's an engineer in this room. That's what I'm trying to say, okay? So I can express this without restriction in the quantifier as this. There exists an x, okay, with no domain restriction. X is in this room, and X is an engineer, okay? Since I'm talking about existence, it makes sense to use and here in between, because the thing I'm talking about, whose existence I'm talking about, is in this room and also has this property, being an engineer, okay? On the other hand, if you have a universal quantifier and your domain is this room, for all x in this room, x is an engineer. What I'm saying is everybody in this room is an engineer. That's what I'm trying to say. So I should express this as for all x, if x is in this room, then x is an engineer, okay? But not for all x, x is in this room and x is an engineer. Because if I say that, what I'm saying is all people are in this room and all people are engineers, okay? Think about this statement. Clearly, it's not equivalent to the original one, because it's not saying everybody in this room is an engineer. On the other hand, it says every person possible in the world, in the universe, whatever you think of, every person now is in this room and all of them are engineers. clearly that is not the same thing I'm trying to say.